Primordial soup is a term introduced by the Soviet biologist Alexander Oparin. In 1924, he proposed a theory of the origin of life on Earth through the transformation, during the gradual chemical evolution of molecules that contain carbon in the primordial soup. Biochemist Robert Shapiro has summarized the primordial soup theory of Oparin and Haldane in its mature form as follows: early Earth had a chemically reducing atmosphere. This atmosphere, exposed to energy in various forms, produced simple organic compounds. These compounds accumulated in a soup, which may have been concentrated at various locations. By further transformation, more complex organic polymers and ultimately life developed in the soup. A reducing atmosphere, whether the mixture of gases used in the Miller-Urey experiment truly reflects the atmospheric content of early Earth, is controversial. Other less reducing gases produce a lower yield and variety. It was once thought that appreciable amounts of molecular oxygen were present in the prebiotic atmosphere, which would have essentially prevented the formation of organic molecules. However, the current scientific consensus is that such was not the case. Monomer formation. One of the most important pieces of experimental support for the soup theory came in 1953. A graduate student, Stanley Miller, and his professor, ALll Urey, performed an experiment that demonstrated how organic molecules could have spontaneously formed from inorganic precursors, under conditions like those posited by the Oparin-Haldane hypothesis. The now famous Miller-Urey experiment used a highly reduced mixture of gases methane, ammonia and hydrogen to form basic organic monomers, such as amino acids. This provided direct experimental support for the second point of the soup theory, and it is around the remaining 2 points of the theory that much of the debate now center. Apart from the Miller-Urey experiment, the next most important step in research on prebiotic organic synthesis was the demonstration by Joan Oracubed that the nucleic acid purine base, adenine, was formed by heating aqueous ammonium cyanide solutions. In support of abiogenesis and eutectic ice, more recent work demonstrated the formation of S-triazines, pyrimidines, and adenine from urea solutions subjected to freeze-thaw cycles under a reductive atmosphere. Further transformation, the spontaneous formation of complex polymers from abiotically generated monomers under the conditions posited by the soup theory is not at all a straightforward process. Besides the necessary basic organic monomers, compounds that would have prohibited the formation of polymers were formed in high concentration during the Miller-Urey and Oracubed experiments. The Miller experiment, for example, produces many substances that would undergo cross-reactions with the amino acids or terminate the peptide chain. See also, common descent, entropy and life. References